In this class, I'm going to explain you about tuned radio frequency receivers and super heterodyne receiver. Okay, so in previous classes, we discussed about AM transmitters and FM transmitters. These transmitters are used to to transmit the modulated signal. So depending on the modulation technique, we use the type of modulator, that may be amplitude modulator or frequency modulator. So here the receiver is an electronic equipment which picks the desired signal and reject the unwanted signals, and the desired signal will be demodulated to get the original signal, to get back the original signal, that is nothing but modulating signal. That is the function of receiver. So receiver is nothing but an electronic equipment which picks up the desired signal and rejects the unwanted signals, and that desired signal will be demodulated so to get the original signal. So that is nothing but the function of receiver. See here, these are the functions of receiver. So the receiver always select the desired signal from the transmitting antenna and reject the unwanted signals, and these desired signals will be amplified by the RF sections. So this signal is called RF signal, and this RF signal will be passed through the demodulator circuit. Here the demodulator or detector extracts the original information from the modulated signal. So finally the modulating signal will be amplified by the audio frequency amplifier. So these are the functions of radio receivers. So generally the blocks which are included in the receiver are RF amplifier section and IF amplifier section and a demodulator section. So RF signal is nothing but the modulated signal. It will be called RF signal. This will be amplified by the RF amplifiers, and the desired signal will be selected from those amplifier sections, and remaining signals will be attenuated. After that, it will be given as input to the demodulator circuit. We know that the demodulator or detector extract the original information from the modulated signal. This is nothing but this is the process of getting back the original signal from the modulated signal, and this what we get at the output of the demodulator. So we will get audio frequency signal that will be amplified by the audio frequency amplifier. So these are the functions of radio receiver. So if you want to design a radio receiver, what are the requirements for the designing? So depending on the application, so whether it is AM or FM signal receiver, so depending on the application, you have to choose. And after that, so the receiver will be able to amplify the desired radio station, and it rejects all other frequencies. Means it filter out all other stations. Only it will be tuned to the particular radio station. And after that demodulator, it will be work with all radio stations regardless of the carrier signal which will be used. Okay, so these are the designing procedure for the receiver. These are the requirements to design a receiver. Okay, so and depending on the application, we can classify these radio receivers into different types, and AM receivers, FM receivers, communication receivers, and so on. So AM receivers. So this will be used to used to receive the AM modulated signal from the transmitting antenna. And these AM receivers, which will operate on long wave, medium wave, and short wave bands. And in FM receivers, it will be used for very high frequency and ultra high frequency bands. And the communication receivers, it will be used for the short wave telephone signals, reception of short wave telephonic signals. And we have another classifications, television receivers and radar receivers also. And depending on the fundamental aspects, so these are the classifications which will be depending on the type of modulation technique we used and type of the application. And here the depending on the fundamental concept, we can classify any radio receivers into two types: tuned radio frequency receiver and super heterodyne receivers. Tuned radio frequency receivers and super heterodyne receivers. So what are the differences between these two receivers? So in tuned radio frequency receivers, it will be composed of only RF amplifiers and detector sections. But in super heterodyne receiver, we have another block included that is called IF amplifier or mixer. So IF amplifier, it converts the RF signal into the down frequency that it will be called as intermediate frequency. And in tuned radio frequency receivers, so no frequency conversion is needed. Only it will be composed of RF amplifier sections and detectors. So generally it will not be used because it will very difficult to design the tunable RF stages because we have the number of modulated signals. So here the RF stage will be able to select or pick up the desired signal and rejects all unwanted signals. So that is very difficult to design the tunable RF stages, and also it will be very difficult to obtain high gain RF amplifiers. High gain RF amplifiers. So that's why it is not often used. So super heterodyne receiver, it converts the RF signal into the down frequency or intermediate frequency. And here the main amplification takes place at IF stage. So these are the differences between the tuned radio frequency receivers and super heterodyne receivers. In super heterodyne receivers, we have RF amplifiers and detectors only. In super heterodyne receivers, we have RF section, IF section, and detector, three sections. Here, the RF signal will be converted into the intermediate frequency in the super heterodyne receiver. And this tuned radio frequency will not be used because it is very difficult to design the tunable RF stages, and also it is very difficult to achieve high gain RF amplifiers. So these are the drawbacks in tunable radio frequency receivers, and these drawbacks will be overcome by super heterodyne receiver. And we have another classification, that is a communication receiver. It also don't convert the RF signal into two intermediate frequencies. So which is the topic we left in the previous classes, communication receivers. Okay. So this is the tuned radio frequency receiver. So see here, what are the blocks included? So it can composed with the RF amplifier stages and a detector stage. So, and here no frequency conversion is needed in the tuned radio frequency receiver. And the detector output will be the audio frequency signal, which will be amplified by the audio frequency amplifier. And finally, what we will get at the output? We will get the modulating signal at its output. So these are the general block diagram of a tuned radio frequency receiver. But here the RF amplifier stages or two or more stages will be included to select the desired signal from the from the transmitting antenna. So this is the actual block diagram of the tuned radio frequency receiver. What are the main blocks? RF amplifier block and detector stage. And we have finally audio frequency amplifier stage. In RF stage, we have number of RF amplifier sections, and the modulated signal will be passed through these RF amplifiers, and finally we will get the desired signal that will be demodulated by the demodulator, and we will get the audio frequency signal, and that will be amplified by this audio frequency amplifier, and it will be given as input to the speaker. So here these three are the RF amplifiers which selects the desired signal from the transmitting antenna. So these are the blocks. RF section, it will be 2 or more stages of RF amplifiers and required to filter the modulated signal, and this will be used for the amplification. So this amplification will be done, and it will amplify the received signal to the sufficient level to drive to the next stage. And AM detector, it modulates the AM wave and converts it, get back to the original information. And audio section, it is used to amplify the recovered signal. So that is called audio frequency amplifier. So what are the advantages of tuned radio frequency? So this is the frequency range of the TRF receiver, 535 kilohertz to 1640 kilohertz, and it has high sensitivity. And we have the some parameters for the receivers. So those are selectivity, sensitivity, dynamic range. So these parameters defines the performance of the receiver. Okay, so ఇవి మనం నెక్స్ట్ క్లాస్ లో డిస్కస్ చేద్దాము. ఓకేనా? సో దీస్ పర్ఫార్మెన్స్ parameters gives the performance of the receiver. And disadvantages of the tuned radio frequency receiver. So we already discussed what are the drawbacks of the TRF receiver. It is very difficult to design the RF tunable stages, and it will be very difficult to achieve high gain RF amplifiers. Okay, so these are the drawbacks. And also we have the instability and variation in the bandwidth, and also poor selectivity. So poor selectivity and poor audio quality will be the drawback of the tuned radio frequency receiver. So these instability and poor audio quality, these drawbacks will be overcome by the super heterodyne receiver. So we know that due to high frequency, we know that RF amplifier stages are multi-stage amplifiers. So these multi-stage amplifiers are very susceptible are breaking into oscillation. Oscillation is nothing but if any small feedback occurs, it leads to the oscillation. If any small feedback occurs from the input to the from the output to the input in multi-stage amplifiers, it leads to the oscillations. So that is the drawback of the instability. That is the drawback. So the device forced to work as an oscillator instead of an amplifier. So that is the instability in the tuned radio frequency amplifier. Okay, so these are the drawbacks, and also poor selectivity. Okay, so these are the drawbacks, and these problems will be overcome by the super heterodyne receiver. So in super heterodyne receiver, the RF signal will be converted into the IF signal, and then the main amplification will takes place at the IF stage, intermediate frequency stage. And also another classification, we have communication receiver. So next, super heterodyne receiver. In super heterodyne receiver, we have three main blocks. One is the RF stage, and next intermediate frequency stage, and next we have detector, and after that audio amplifier. This will be same as in the tuned radio frequency receiver. Tuned radio frequency receiver. So these are the main blocks which are included in the super heterodyne receiver. So first one is the radio frequency section, amplifier section, and next one is the intermediate frequency section, and next one is the detector, and after that audio frequency amplifier. And here the RF section and IF section will be connected to the ganged tuning. Will be connected to the ganged tuning. So here the circuit itself tuned to the intermediate frequency, selected intermediate frequency. Okay, so depending on the received modulated signal, the circuit itself adjusted to the intermediate frequency. So if you want to convert this RF signal into intermediate frequency, we need a mixer circuit. We need a mixer circuit. This down converts the RF signal into intermediate frequency. Okay, so for this mixer, we have two inputs. One is the modulated signal and another one is a local oscillator. So finally, what we will get? An intermediate frequency. Okay, so heterodyne means mixing the two signals. That is nothing but heterodyne, mixing the two frequencies together in a non-linear device and transmit one frequency into the another frequency. Okay, so that is the meaning of heterodyne. Means here the frequency conversion takes place. So high frequency should be converted into the down frequency by using a mixer. So that is called intermediate frequency. That down frequency or low frequency is called the intermediate frequency. So this super heterodyne receiver always converts the RF signal into lower frequencies. So those are known as intermediate frequencies. What are the drawbacks overcome in the super heterodyne receiver? So stability and the variation in the bandwidth and better selectivity. What are the disadvantages? What are the drawbacks occurred in the tuned radio frequency receiver? So those drawbacks will be overcome by the super heterodyne receiver. So here we can achieve the stability because the high frequency will be converted into the low frequency, intermediate frequency. So this will leads to the stable frequency. This will leads to the stability in the frequency and no variation in the bandwidth. So, and we have variations in the bandwidth in tuned radio frequency receivers. And because of the high frequency variations, the bandwidth will be varied. And here in the super heterodyne receiver, the RF signal will be converted into the intermediate frequency. This is the range of intermediate frequency. So almost the bandwidth will be constant within this range. And we have the better selectivity. So because of the constant bandwidth, we will get the better selectivity. Better selectivity means it can pick the desired signal. It can pick the desired signal. So this is the actual block diagram of the super heterodyne receiver. So you may observe the RF section and a mixer. It will be converted the RF signal into the intermediate frequency, and this will be the IF section. RF and mixer, IF section, and we have the demodulator or detector section, and finally we have the audio frequency amplifier. So here you may observe a pre-selector and a local oscillator. What it will be called a ganged tuning. So here from the transmitting antenna, we have the number of signals. This pre-selector detects the desired signal, and this will be passed through the RF amplifier sections. And depending on this selected signal, it will be converted into the intermediate frequency because of this ganged tuning. So here we have to use a mixer to convert the RF signal into the intermediate frequency. For this mixer, we have two inputs. One is the modulated signal, that is called RF signal, and another one is will be generated from the local oscillator. So finally, we will get the intermediate frequency. and it will be passed through the band pass filter sections and IF amplifier sections. And finally, this IF signal will be given as input to the detector or demodulator. So demodulator extracts the original information from the IF signal, and this will be amplified by the audio frequency amplifier. And this will be given as input to the speaker. And what is the final stage? That will be speaker. So these are the blocks. In RF section, how many blocks we have? Two blocks. One is pre-selector and another one is RF amplifier. So what is the purpose of pre-selector? So pre-selector is nothing but a tuned band pass filter with adjustable center frequency. So here you may observe it acts as a band pass filter. We know that the band pass filter, it allows the particular band of frequencies. It allows the particular band of frequencies, and other than that band, it rejects. Other than that band, it rejects. And what is the flexibility in this band pass filter? It will be tuned band pass filter with adjustment in the adjustable center frequency. So depending on the received signal, so we can it can adjust the center frequency so that it selects the desired band and rejects the unwanted band. So because of that, we can reduce the noise and also bandwidth. And after that, RF amplifier. So this RF amplifier receive the filtered signal, and this will be amplified for the further stages. Okay. And after that, we have mixer. For this mixer, we have two inputs. One is coming from the radio frequency amplifier section and another one is from the oscillator, local oscillator. So here the oscillator choice depends on the stability and accuracy. This will choose depending on the requirement we can choose. So that may be stability requirement, or depending on the accuracy, we can choose the type of oscillator. And here the mixer is a non-linear device. It converts the radio frequency signal into the intermediate frequency, and that process is called heterodyne process, heterodyning process. Here, the bandwidth and the original information remains unchanged. What we are doing here, we are converting the high frequency signal, RF signal, into the intermediate frequency, down frequency. Here, whatever the information that will be contained in the RF signal, so that is not affected. That is not affected. So same information, but the frequency RF, what we are converting that signal RF frequency to intermediate frequency, and the information will be remains unchanged. Okay, so that is the mixer section. And next to intermediate frequency section, that is we have to use IF amplifiers and band pass filters to achieve the more gain and more selectivity. Here the selectivity is depending on the quality Q factor. If Q is very high, the selectivity also high. Okay, so to achieve the high gain and more selectivity, we have to use band pass filters and also amplifier sections. So here band pass filters are used to get more selectivity, and the amplifier sections will be used to get more gain. Okay, so always the intermediate frequency is lower than the RF frequency. So these are the IF amplifier sections. And detector section, we know that it converts the IF signal into the original information, and this detector section will be include. It is a PLL, phase locked loop, or it may be a balanced demodulator. Okay, so depending on the AM receiver, whether it is AM or whether it is frequency modulation frequency modulated wave, so we have to use these. And audio amplifier sections. So this audio amplifier is the cascading of several audio amplifier sections. It strengthens the demodulated signal, and it will be given as input to the speaker. for the impedance matching, we have to amplify the demodulated signal. Okay, and in IF amplifiers, in sometimes we have to use an automatic gain control. So దీని గురించి మనం నెక్స్ట్ క్లాస్ లో డిస్కస్ చేద్దాము. ఆటోమేటిక్ గెయిన్ కంట్రోల్ అనేది ఎక్కడ యూస్ చేస్తాము ఏంటి అనేది. సో దీస్ ఆర్ ద 2 types of receivers. So tuned radio frequency receiver and another one is a super heterodyne receiver. Okay, so we know that what are the drawbacks, the selectivity and stability. These are the main drawbacks, and these drawbacks will be overcome by the super heterodyne receiver. Okay, so in AGC AGC గురించి మనం నెక్స్ట్ క్లాస్ లో డిస్కస్ చేద్దాము. టైప్స్ ఏంటి AGC లో అనేది. Okay, so this is the actual block diagram, how it converts. For example, here the modulated signal will be like this, and this one is the center frequency, and upper sideband frequency and lower sideband frequency. These are the band of frequencies in the modulated signal. First, it will be passed through the pre-selector section and RF amplifier section, and finally it will be passed through the mixer. See here, you may observe the center frequency will be converted into the intermediate frequency. So 400 kilohertz will be converted into 450 kilohertz. So here the information will be same, but the frequency will be down converted. And after that, it will be passed through the IF amplifier sections and band pass filter sections. So you may observe this band pass filter only passes the desired band of frequencies. So what is the desired band here? 450 kilohertz to 460 kilohertz. This will be the desired band. And after that, it will be passed through the detector section. And after that, we have to use a demodulator section. So here, if the modulated signal frequency is 900 kilohertz, so you have to choose the local oscillator will be so very high when compared to the modulated signal frequency, and it will be given to the mixer. It will be down converted. So you may subtract this one. So 1355 kilohertz minus 900 kilohertz, so it will be down converted. So what is the mixer means? Here it will perform the addition and subtraction. So we have to consider only the down frequencies, intermediate frequencies. Okay, so this is also this is all about super heterodyne receiver. And also we have a drawback in the super heterodyne receiver, that is nothing but image frequency. సో అది కూడా మనం నెక్స్ట్ క్లాస్ లో డిస్కస్ చేద్దాము. ఆ ఇమేజ్ ఫ్రీక్వెన్సీ అంటే ఏంటి, ఆటోమేటిక్ గెయిన్ కంట్రోల్ అంటే ఏంటి అనేది. ఓకే.